Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 12 of a unit electrostatic potential and capacitance. In today's class we are going to discuss about the combinations of the capacitors. This is part 2 of a combinations of the capacitor. In the previous class we have been discussing with the how capacitors can be connected in series, how they can be connected in a parallel, and how can we calculate the equivalent capacitance when this capacitors are connected in series or in parallel. Today we are going to discuss about the somehow certain more advanced techniques of series and parallel combinations. So please have your pen and paper before you start the video, and and calculate the questions with me. So let's begin with today's class. All the best. Let's look at the question. Suppose they have given something like this. 6 microfarad, 6 microfarad, 6 microfarad. This is the point A and this is the point B, and this is not yet complete. Yes, they have connected this. And now they say that find out equivalent capacitance between A and B. This is what the requirement is. Now how can I do this? These three capacitors are connected in series or parallel? Yes. Are they in series or are they in parallel? How could I decide that these people are connected in series or they are in parallel? What can we do? What can we do? So, one option or one trick to find out this kind of capacitance is that when and when we can't just assume that this are in series or this are in parallel, when and when we cannot see the situation clearly, what we can do is we can naming the different points. Now how I can give the name, let's have a look. That this point is at A, so even this point must be at the same name. Basically we are talking about the potentials, but do not make it complicated by name it as a potential. You just give them as a name. Yes, so if this point is at B, this point is at B, what is the concept is you can give the same name, give the same notation when there is no capacitors. If there is a capacitor, if there is a capacitor is there, then you need to give the different name. Yes, so let's move on with on this wire, that's this wire, this wire, this and this. Between this path no capacitor has been found, so I can give it, I can label it the same name, it's an A. From here it's an B. So if you are moving on this wire, let's have a look. If you are moving here, do you find any capacitor in this path? No. So if no capacitor has been found, so you can give the same name as it is a B. Now let's look that every symbol or every connection have their names. So I think I have done with my part. Now what I need to do is I need to just reconstruct this circuit so that it look like that whether this are connected in series or they are connected in parallel. So how can I reconstruct it? Let's have a look. That first, when and when you need to find out the equivalent capacitance between this two, it's an A and B, put them on the end parts of the circuit, then try to start making the circuit. It's what I can have is that I must have a one capacitor between A and B, and it must be having a value of 6 microfarad. So what I can draw is that this is my one of the capacitor between A and B, and its value is 6 microfarad. For simplicity, just cut that capacitor. So you must remember that this has been drawn. Yes. Now let's move to the next. Here this is B, here this is A, and between this B and A one more capacitor is there. It is having the same capacity. So from B to A, from B to A I must be having one capacitor. So let's look at this. This is the capacitor from B to A. This would be 6 microfarad. Yes. So this has been done. Cancel it. One more capacitor starting from the A and ending on the B. Starting from the A and ending on the B. One more capacitor is there which is of 6 microfarad. So let's have, this is the third capacitor. Yes. So this is of 6 microfarad. Now tell me, these three are in series or parallel? Yes, it is in the parallel, and when they are in parallel, C equivalent would be equals to 6 plus 6 plus 6 microfarad. So this will be total as of 18 microfarad, and that's it. I hope this is clear. Is it? Is it clear? Are you sure? Any confusion in this? Is there any confusion in this? Do you have any confusion in this? Do you? No? So can we move? Can we move to the next level? Can I? Can I? Okay, let's have a look to the next. Let's suppose the question is something like this. Circuit is that this is of 8 microfarad. This is of 4 microfarad. This is of 2 microfarad, and this has been connected. Yes. What they find is, find out C equivalent of the given circuit. This is the requirement, that you need to find out the C equivalent of the given circuit. So what can I do? One of the option, you can see it clearly. If not, let's have a marking on them. Let's say this is A, this is B. From here to here there is no capacitor, so I can give the same label, it's in B. From here, no capacitor, so I can give the same label, it's in B. I hope these things are clear to you. Yes. Now from A to, I am moving on this path, but capacitor is there. Capacitor is there, so let's give them a name as a D. Yes. So now this has been connected and having one more capacitor, so already a different name, so you have labeled it correctly. Now if you are moving on this path, one of the capacitor is there, so you must be labeled with different name. So it is different. Yes, correct. Now if you are moving on this path, one more capacitor is there, so if you wish, you can label it as an E. Yes. So what what next? What we need to do is that we need to find out the equivalent capacitance, and to find out the equivalent capacitance, we must redraw this. So how could I proceed? So let's have that my A should be A, and B should be at the end, and I can put a D and E. Within this, it's a D. Let's say this is E. So let's try to restructure this. First capacitance, it is from A to D. and having a value of 8 microfarad. Cut it. Next capacitance from D to B. Next capacitance from D to B, and it must be of 4 microfarad. So this is D to B, and this is of 4 microfarad. Cut it. S- one more, one more. It's a 4 microfarad and 2 microfarad, something like this. Yes. Now I need to go from D to E, and I need to have a capacitance of 6 microfarad. So this is 6 microfarad, and from E to B it would be an capacitance of 3 microfarad. So thing would look like this. This is the B. Yes, I hope this is clear to you. Now now is it visible clearly? Is it? Yes. So what you guess is that this construction, this is parallel combination. This is parallel combination, and with this C equivalent, this has been connected in series. I hope these things are clear to you. Yes. Yes. So can you calculate this? Yes. Let's have a calculation of this, but let's have it quickly. That this is 2, this 6 and this 3 are connected in. Yes, this 6 and this 3, these people are connected in, they are in series, and when they are in series, they must be equivalent of 6 into 3 divided by 6 plus 3. So this is 2 microfarad. So the situation look like that. This is 2, again this is 2, and this is of 4, that has been connected with this, that is 8 microfarad. So this 2 and this 2, this is 2 plus 2 4, 4 plus 4 8. So the thing would be, let me redraw this, that this is the 8 microfarad. Even this C equivalent would be of 8 microfarad. So if I solve this, if I solve this, it is the situation like that. This two are connected in series. This is A, this is B. So their C equivalent would be, it's an 8 into 8 divided by 8 plus 8. So this is 8 8s are 64, divide by 8 plus 8 16. This is 16 4s are 64. This is 4 microfarad. I hope these things are clear to you. Is it? So now I hope you can do this kind of questions. Are you sure? Can it be done by you people? Do you? Are you sure? Okay, so let's move to the next concept. Let's move to the next concept. It is a concept of Western bridge. This all are the tricks and techniques to solve the networks. This all are the tricks and techniques to solve the networks. You must remember the situation, that how my network should look alike, and what could I apply to it. So let's work for the Western bridge. Suppose you have been given a network something like this, and your potential difference has been connected on this. Let's say this is capacitor P, this is Q, this is R, this is S, and let's say this is capacitance T. Here the V volt is there. So for balanced Western bridge, for balanced Western bridge, now the thing remain is what balanced Western bridge all about. We are going to derive this in unit number 3, but here we are just seeing, here we are just having a look at the application of this. So I know that if P by Q, I'm talking about the ratio of this to the this, is equals to the R by S. If P by Q is equals to R by S, then this point, let's give it a name as an A, and this is a key. Then point A and B is at same potential, and no charge is flowing. No charge is flowing through capacitor T. This is Western bridge, or I can say balanced Western bridge. So this is very good application. In fact, if you understand this very carefully, that you what you need to find out, that you need to check a ratio of this. It's a P by Q as to the R by S. Yes, if this the ratios are same, then you can remove this, because no charge is flowing through this. And if no charge is flowing through this, and if you have disconnected this, then your P and R would be in series, your Q and S would be in series, and equivalent of P and R is parallel with the equivalent of Q and S. Yes, things would be much easier. I hope this is clear. But I want to have a mark on one more very important point, is that when you understand that whether it is a Western bridge or not, you must understood that the fifth capacitor which you are going to eliminate should be on the different diagonal than the diagonal on which battery is connected. Now look at this. Battery has been connected on this diagonal, and this fifth capacitor has been connected on this diagonal. These two diagonals are the different one. They cannot be the same. And if they are the same, this is not a Western bridge. I hope these things are clear to you. Did you get me? Do you? Yes. What I mean to say is that the fifth capacitor and connection of battery should be on opposite diagonals. If they are on same diagonal, it is not an Western bridge, it is the simply a parallel network. For your help, we are going to take one of the question on this. Yes, so shall we use this? Are you ready with this? Let's have a look. The question is that suppose the network is given that this is 4 microfarad, this is 8 microfarad, this is 2 microfarad, and this is 4 microfarad, this is 10 microfarad, this is point A, this is point B. They want that to find out equivalent capacitance between A and B. This is their requirement. Find out the C equivalent between A and B. Yes, so battery has been connected on this diagonal, and fifth capacitor has been on this diagonal. So what I need to check is that I need to check what should be the ratio of P by Q is to R by S. So this is my P, this is Q, this is R, and this is S. So let's have a ratio of P by Q. It's in 4 microfarad divided by 8 microfarad. So this would be a 1 by 2. Let's check it out. The value of R is 2S. So my R is 2S. It's a 2 microfarad divided by 4 microfarad. So again it's a value of 1 by 2. Yes. So as I can see that P by Q and R by S having the same ratio. So there is not any significance of this 10 microfarad, and I can just remove it. So if I remove this, my equivalent network will look alike that something like this. Let me redraw this. That here it would be a 4 microfarad, and in series with it, it's a 2 microfarad. On this side, it's an 8 microfarad, and here it is a 4 microfarad. This is the A, this is the B. Yes. Now you need to find out the series and parallel combination. So this two are in series. So their equivalent would be 4 into 2 divided by 4 plus 2. Yes, it's an 8 divided by 6, which is 4 by 3 microfarad. And the lower side, it's a 8 fours are divide by 8 plus 4, it's a 12. So this is 4 by 3, this is 8 equals to 8 by 3 microfarad. Now as you can see that this two are connected in parallel, and when they are connected in parallel, my C equivalent would be equals to 4 by 3 microfarad plus 8 by 3 microfarad. This is equals to 4 plus 8, it's a 12 by 3. So this will be a 4 microfarad, and things has been done. That's it. Yes. So can you do this kind of questions? Can you? Are you sure? Can it be done? Can it be? Yes. So let's have one more question. Let's have, and let's look at this very carefully. This is A, this is B, this all are C. They say find out CAB. I hope you understand this. It's an equivalent capacitance between A and B. So how can I do this? How can I do this? Any idea what could be done? Can you see this? That whether this are connected in series or whether this are connected in parallel, what should I do? Any idea? Yes, this is the situation where I cannot see that clearly that this are connected in series or this are connected in parallel. What I need to do is I need to simply label this. So let's begin with the labels. That this is A, and as soon as I'm moving on this path, no capacitor is there, so I label it as an A. Now let's move on this path. Yes, but capacitor is there, so I need to give it a new label. It's an, let's say this is A, so now this is D. Yes. Now let's look at this is B, and moving on this path, this is again a same label because no capacitor is there. This is B. Now moving on this path, as I'm moving on this path, a capacitor has been found, so I should ended up with the new label. This is E. So any connection which has been left, is there any connection which has been left? No. So as no connection has been left, I can start doing the simplest circuit making process. So what you need to do is you just simply pause the video and try to make the construction, try to make the simplest diagram of this. If you cannot do it, just play it, and I am here to guide you. So what you need to do is, because this is the thing, this is all about the practicing the questions, because there are so many questions, but we have a very limited amount of time. Yes. So I'm trying to cover each and every format, or each and every, what we can say, a pattern of the questions. Yes, but you need to practice it hard so that you can observe this very carefully. So just pause it, and if you cannot do it, I'm here to help you. So let's have a look. What I can have is that one of the terminal is A, another is the B. Put them on two endpoints. It's an A, it's an B. One more point, it's an E and it's an D. So let's say this is E and this is D. So now what you need to do is you need to put a capacitor. So let's move on this path, A to E, having one capacitor. So this is A to E, having one capacitor. You have drawn this, cancel this. Next Next is the E2D and having one capacitor. So this is something like this. It's an E, it's an D. Next, it's an from A to D on this path having one capacitor. So this is A to D. Yes, cancel this. Next, next is the D to B having one capacitor. Yes, so this is from D to B having one capacitor. This is that. Cancel this. And one more from E to B having one capacitor. So it should look like this. I hope these things are clear too. Is it? So this is C, this is C, this is C, this is C, and this is C. So now what you need to do is, can you observe something very interesting? Can you observe this? Yes. Do you? Yes. You can label this as an P, Q, R, S. So find out the value of P by Q. It's a C is to C. It's a 1. Find out the ratio of the R is to S. It's a, again C is to C. It's a 1. So the ratio is same. And if the ratios are the same, what you need to do is you need to simply remove this fifth capacitor. So the network will be that something like this. It's a C, even this is C, this is C, this is C, and that's it. Yes. So this is A, this is B, this two are in series, this two are in series. So if I make a diagram of this, or I can say a simplified diagram, it's an C to C, it's a C by 2. I hope you can do this. C to C, it's a C square divided by 2C, so it would be a C by 2. And just simply add this. So this is C by 2 plus C by 2 will give me a C. This is my final answer. Is it clear? Is it? So can you do this? Are you sure with this? Are you sure? Yes. One more question of Western Bridge. Yes. Let's have it. But please make it quickly. Hmm. Let's say this is 2C. This is C. This is 2C. This is C. And this is C. This is A. This is B. What they will ask that find out CAB. Now what you will do, pause the video and have your answer. Once you done with this, just come back and play the video. So as you are coming back, what is your answer? Is it a balanced Western bridge? Is it? So many of you have assumed that yes, they are the five capacitors. I will take a ratio of this P is to Q and this R is to S, and this the fifth C will be cancelled out and something like this. But you are absolutely incorrect. Yes. Why? Because look at this. As I have said that C equivalent and the fifth capacitor, that means the battery that has been connected and the fifth capacitor must be on different diagonals. Here this are in the same diagonal. So what the situation will happen, is that if I connect a battery over here, the charge is flowing. Certain charge will be going through this, another certain would be going through this, and another certain would be going through this. So this is not a Western bridge, this is simply the parallel combination. That means this two are in series, this two are in series, and this three, that means the equivalent of this, and this C, they are in parallel. So let me solve this. It's a 2C 2C, they are connected in series, so that will give me a C. This is already a C, and the this it's in C by 2. This is A and this is B. So if I find out the C equivalent, it would be a C plus C plus C by 2. It's a 2C plus C by 2. It's a 2C plus C by 2. It's in 5C by 2. This is what all we require. That's it. I hope this is clear. Is it? Is it clear? Any doubts on this? Any? No? So shall we move to the next concept or next pattern? Are you sure? Let's move on then. Next, what we need to find out is concept of plate capacitor. Now, what is plate capacitor and what is plate configurations? So what they will ask sometime is that, let's say first, second, third, fourth, and fifth. These five plates are there, and this five plates have been connected with this, that this has been connected with certain point A, and this has been connected with certain point B. I can see that every plate has a separation of D, and they just ask that find out CAB, find out CAB. So what I need to do is that I need to make a capacitor between these plates. Now I know that that two plates can make a one capacitor. So what I know is I can form one capacitor from this. I can make one more capacitor from this. I can make one more capacitor from this, and one capacitor from this plates. So totally I can have a four capacitors. So let's give them a names. This is at A, and as there is no other plates have been connected or no other capacitors are there, so this is A. Even this plate should be named as an A. Even this plate should be named as an A. And as it is a B, this is to be named as an B. This is to be labeled as a B as well. So now let's have a diagram of this. That on a one side I would be having an A, on the other side I would be having with the B. So there should be a one capacitor between A and B. Let's draw it. This is done. Let's have one more between B and A. So this is it. Let's have one more with an A and B, something like this. This is done. And have one more, it's a B between A. So this is C, this is C, this is C, this is C. So the C equivalent would be equals to 4C. If you wish, you can have it like 4 epsilon naught A by D, and the things will be done. Yes, this is the plate capacitors. What is the benefit of this? What is benefit of this? Look at this. You have made the 4 capacitance using this. If you make a single capacitor, then that capacitor will require two plates, at least two plates, I should say this. So if four capacitors are there, it would require an 8 number of plates. But here we have done this task with the help of only 5 plates. 1 2 3 4 and 5. Here we have used only the 5 plates, and our task has been done. I hope you understood this. Is it? So we require a lesser space, and we can form the same capacity with the help of this plates capacitors. Yes, like to do one more? Yes, like to do one more. Let's have a look on this. Let's have a look. That let's suppose 1 2 3 and 4. this plate has been connected with A, this plate has been connected with the B. So you need to find out that find C equivalent of given network. This is the requirement, find C equivalent of given network. So what should I do? Let's give them a name. This is A, this is B. These two are the different one. So what I can write is I can write them as a D and E. Yes, I can make one capacitor between this, one between this, and one between this. So let's have a simplified diagram of this situation. This is A, this is B, and I need to write them this as a D and D. So what I required an one capacitor between A and D. So let's say this is the that capacitor, this is A and D. One more capacitor between D and D. This is that capacitor, this is D. One more between E and B. So this is that, it's a C. So if I find out this is CAB, this are in series, and as they are in series, it's a C divided by 3. So if they have been given, it's an epsilon naught A by D. So this is epsilon naught A by 3D. This is the C equivalent. This is the C equivalent of the given network. I hope this is clear. Is it? Is it clear? Yes? Is it clear? Are you done with this? Are you? So can you do this kind of questions? Will you be able to do this questions? Are you sure? Or shall I add something to this? Shall I add? Yes. The question is that in the previous diagram, find out charge on each plate of a capacitor. You need to find out the charge on each plate of capacitor. Now how can you do this? What can be done? So let's redraw that structure. 8, 2, 3, 4. This is A, and this has been given as B. And let's give the numbers to the plate. This is first, second, third, fourth. As I have made the diagram of this, that it would be look like first, second, and 3 capacitors were there in the series. And let's say it has been connected with the battery. Let's say it has been connected with the battery, and it is something like this. So a terminal, this is the positive terminal of the battery. Even this plate is connected with the positive terminal of the battery. So what I can write is that this is the first plate. This is the first plate of a capacitor, because it has been connected with the positive terminal of the battery, and I have formed capacitor 1 between this 1 and 2. So if this is 1, this is by obvious it's a 2. Now I have made one more capacitor between 2 and 3. So this plate has been given name as a 2, and this plate has been given name as a 3. Now fourth plate has been connected with the negative terminal. So this is fourth and this is third. I hope this is clear. Is it? Is it clear? Yes. So let's say I have given a charge, a potential of V between this. So what I can have is that Q total should be is equals to C equivalent multiplied by V, and the C equivalent would be is equals to epsilon naught A divided by 3D multiplied by V. This is Q is equals to CV, because this is my C equivalent. Now as this are connected in series, that this Q will pass through all of this. So a plate number 2 is twice, plate number 3 is twice, and plate number 1 and 4 is on one time only. So I can say charge on first plate, charge on first plate, it's a epsilon naught A by 3D into V. Charge on fourth plate, it's an epsilon naught A by 3D into V. Charge on second and third plate, as they are coming the twice of time, because it has been connected with the two capacitors. So so as it has been connected with the two capacitors, that this is 2, this is 2, yes, it's a total charge we are discussing about epsilon naught A by 3D into V multiplied by 2. This would be the situation. I hope these things are clear to you. I hope these things are clear to you. Is it? Is it? Yes? Yes? Yes. We are talking about the net, we are talking about the total charges here. We are here talking about the total charges. So we are just want the mode of the charges. We always think that we are interested in the total amount of charge, not the what the positive and not the negative. So this is the concern. I hope these things are clear to you, and you will be able to solve this kind of questions. So now concept of plate capacitor is clear to you. Is it? Is it clear? Yes. So can you do this kind of questions? Are you sure? Are you sure? Yes. So let's look at the next concept. It's a concept of infinite ladder. Have you seen this kind of questions? Infinite ladder kind of questions. Have you? It look like this. That suppose the thing would be something like this. And this has been gone to the infinite. So this is C, 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 and this is point A, this is point B, and we have been asked that find out CAB. We have been asked this, find out CAB. How can we do this? What can be done? How do you calculate this? So what you can do is, you can just assume that from where my circuit is being repeated, so if you observe this very carefully, this is the segment where it has been repeated. Look at this, this C, this C, this C, this C, this C, this C. Yes, so this segment has been repeated. So just segregate this, from here, and replace this capacitance, that this is C, this is C, and the whole total remaining network would be called as, let's say, X, as well as my answer would be X. So my C equivalent, let's say it would be an X. So this is the situation, and this is point A, this is point B. Now tell me, what can I do? Yes, I hope you can observe this, that this C and this X, are in parallel, and if these two are in the parallel, what I can have is that this is C, this would be a C, and this would be an X. My C equivalent would be X, and that would be equals to, these two are in series, oh sorry, these two are in parallel, that means this is C plus X, and the equivalent of this is in series with this. So what I can have is multiplication of this and addition of this, it's a C plus X. So it is x is equals to c into c square plus cx divide by 2c plus x. So if I solve this it's a 2cx plus x square is equals to c square plus cx. So this is x square plus cx, because this is 2cx, this is minus of cx, minus of c square is equals to 0. As it is a quadratic equation, I can compare this with ax square plus bx plus c equals to 0, and I can have a root of this. So when you solve this you will be having an answer that is of c equivalent would be equals to root of 5 minus 1 by 2 into c. This would be the answer. C equivalent would be is equals to root of 5 minus of 1 divided by 2 into c. I hope these things are clear to you. Is it clear? Yes, are you sure? Would you like to see one more? One more of later? Let's did it. The next question, that this is C. This network is C. This is A. This is B. Now this is 2C. This is 2C. Next, this is 4C. This is 4C, and this has been moving up to infinite. So what can I do? What can I do? Can you observe any pattern that this are my repeated blocks? Can you see this? As I can see this, these are the repeated blocks. This is C, this is C, but this is 2C, 2C, and here it is multiplied by 2. It's again 4C, 4C, and again it would be a 8C, 8C. So what I can do is that I can assume that the situation would be something like this. This is C, this is C, and I need to replace this network by 2x, as well as my equivalent capacitance between A and B, it is also x. My equivalent capacitance will be always an x, and this is, as it is an x, it is a multiplied by 2. I have assumed it as a 2x. So if I find out the x, if I need to find out the x, what I can do is that I know that this two are in parallel with each other. As they are in parallel with each other, I can have it's a 2x plus c. Yes, and the combination of this has been series with this. It's a 2x plus c into c divide by c plus 2x. I hope now you can make it calculate. Yes, and at the end you will have an answer as a c by root 2. So please do this. This is very interesting questions. Yes, so let's wind it up here. Yes, this is all about the series and parallel combinations of the capacitance, but this is not done. This is not the complete. Yes, there are many more patterns can be there. Even we are going to learn some more tricks and techniques with the resistors as well, which is coming in the next unit, and we can directly apply to the capacitors as well. As we are moving in the third unit, we are going to observe it, and even at that point of time I will take some questions based on the capacitor having same concept. Yes, so please do as many questions as possible, because practice makes a perfect. Yes, so thank you, have a good day, take care, bye bye.